Hello everyone, this is question 9 on paper 1 from 2023 Edexcel, and we've got a geometric sequence question. So it says the first three terms of a geometric sequence are 3k add 4, 12 minus 3k, and k add 16, where k is a constant. Show that k satisfies the equation 3k squared minus 62k plus 40 equals 0. Okay, now we're going to use a standard technique here, is that in a geometric sequence we have a common ratio. So that means that the second term divided by the first term is going to give us the same number as if we have the third term divided by the second. Such a common idea. So here the third divided by the second is equal to the second divided by the first. Okay, very, very common idea. And what that enables you to do is once you write that down, you can then cross multiply and get an expression to solve. So I've written that down here and I've cross multiplied, okay, giving me k add 16 times by 3k add 4 is equal to 12 minus 3k times by 12 minus 3k. So when we expand our brackets, we get k times by 3k is 3k squared, k times by 4 is going to be 4k, 16 times 3 is going to be 48k, and 16 times 4 is 64. Over here we have 12 times 12 is 144, 12 times by minus 3 is minus 36, minus 3 times 12 is minus 36, and minus 3k times minus 3k is plus 9k squared. So now we collect our like terms, and when we do that we get 6k squared minus 124k add 80 is equal to 0. Now there's a common factor here of 2, so we can divide everything by 2 and we get 3k squared minus 62k add 40 equals 0 as required. So that's our part A done for 2 marks. Part B, given that the sequence converges, find the value of k, giving a reason for your answer, and then find the sum to infinity. Now I think this is one of those questions where there's quite a bit of work really, considering the amount of marks. So we've got to try and solve this quadratic equation in the first instance to see what our possible values of k are. So I've just subbed this formula into the quadratic formula. So I've got my minus b plus or minus the square root of b squared minus 4 times a times c. Now when you just work that out, that whole thing turns out to be, gives you 2 different values of k. Either k is 20 or k is equal to 2/3. And it's not immediately obvious, you know, which one is the one that's the right answer. I think that with this one, because of the way, there's kind of like a little bit of a trap really, because of the way that this question says the sequence converges, I think a lot of students would intuitively say k must be 2/3 then, because k is less than 1. But it's not quite that straightforward, because what we've got to do is go back to our original sequence and see what the sequence looks like with both values of k. So let's first of all try and see what our sequence looks like when we've got k is equal to 20. So the sequence goes 3k add 4, so we'd have 3 times 20 add 4, so that's going to be 64. The second term is 12 minus 3k, so 12 minus 3 times 20 is going to give us minus 48. Our third term is k add 16, so that's going to be 20 add 16 is 36. Now, when we find a common ratio here, when we divide the second term by the first term, we get minus 3/4. And when we divide the third term by the second term, we also get minus 3/4. So actually, our common ratio here is fitting what we're looking for a convergent series. So it's probably going to be this one, okay? So even though the value of k is 20, the value of r that you get when you sub into the sequence is what we need. Now you probably could just go straight away with it there and say, okay, it must be this one. But just in the interest of completeness, I've just checked with the other one. So when k is 2/3, we have 3k add 4 is going to be 3 times 2/3 add 4, which is going to be 2 add 4, so 6. The next term turns out to be 10. The next term turns out to be 50/3. Now when you divide 50/3 by 10, you get 1.6 recurring, or 1 2/3. And when you divide 10 by 6, you get the same answer. So here we have a common ratio which is larger than 1, okay? Because remember, for a sequence to be convergent, we need the modulus of r to be less than 1, which means that r needs to be less than 1 but greater than minus 1, which it is here, because r is equal to minus 3/4. So that's good. but here it's not because r is bigger than 1. So kind of a little bit, confusing that bit there. So therefore the correct value of r is, or in this case k rather, it says given that the sequence converges, find the value of k, giving a reason for your answer. Yes, well our correct value of k is that k is equal to 20, okay, which gives rise to a common ratio of -3/4. So our answer there is that k should equal 20. Okay, perfect. Right, the next one, we've now got to find our sum to infinity, okay? So our sum to infinity of the sequence. And sum to infinity is given by sum is a over 1 minus r. I have a feeling we're given that in the formula booklet. Let's just have a little look. We're not given an awful lot in the formula booklet, to be fair, but I feel like we could be given that. Let me just have a look. Do I feel like we're given that? Am I missing something here? I probably am. Let's have a look. Where is it? Somewhere in here. Oh, yes, there we go. It's hiding all the way back here. So all the way back here on that page, we are in fact given the sum to infinity is a over 1 minus r. Okay, so that's good. So we don't need to remember that. So the sum to infinity is a over 1 minus r. Now we know that k is 20. We found out that our first term was 64. So the first term is 64. Our common ratio is -3/4. So 64 over 1 minus -3/4 is 256/7, and that's our sum to infinity of that sequence. Quite an interesting question, that one. Especially had to think a little bit about that part B. It was not immediately obvious. I hope you found that helpful, and I'll see you in the next video.